Okay, so the first problem that I'm going to go through is the third problem that I made, where you are going to your cabin in the zombie apocalypse and you're going to create a water treatment facility so you can have fresh water. So to solve this problem, you have the pipes, you have the head, you have all this, and you have the information that you can find through the tables at this specific temperature. And the first equations that you use is the Ergun equation, so that you can find the differential in pressure and the velocity. And the second equation is going to involve using the head. And then what you do from there is you have your elbows and you have the inlet, and you're going to assume the pipes are smooth. You use Bernoulli's equation with the friction. You can calculate the friction factor, and this all should reduce down to finding the Reynolds number, the friction factors, and then in the end that should get you your final velocities and your Reynolds numbers. So the second problem that I have here is a hang glider problem, which I thought would be a nice one for drag. So you have your hang glider, you're going hang gliding off of North Table Mountain, and you're going at 30 kilometers an hour, and the altitude is 100,000 or 1,800 meters above sea level. And so you have your drag coefficient, and you calculate that through the properties you can find. You can find the high altitude properties with the density of air at 1.027, and you multiply it into the equation, and then you can find your drag force. So for the fifth problem that I did in the total sets, I had a shaft in the middle, a cylindrical shaft that rotated, and it had a center filled with lubricant oil and had a bearing that surrounded it. So it was two concentric cylinders. So here are the assumptions I made. I wrote down my initial equations first so I know what to cancel. This is the equations that I got. Here are my boundary conditions, and from there I created a differential equation. It got me my average velocity, and here is my final answer that I produced from those equations. So for my final problem, I did an air compressor, and I had it, you set it up to 250 kilopascals, and you have your outlet, and you have the temperature outside, and you have to find the initial outlet flow of the air. So for this problem, I drew out a little bit of a picture. I found this data from the textbook. What I needed to find was the velocity. I assumed that friction loss inside the tube was negligible and it was compressed flow. I discovered that flow was choked, and so I found the velocity, and at the end I was able to find the mass flow rate out at the bottom.